let's go back to like cells, when cells started to form. So the survival strategy of the individual cell was like, hey, let's form a membrane around us and have these organelles inside that do all this stuff. But our survival strategy is to create a barrier between us and the environment outside of us. But they would passively move through the environment. They were in a liquid medium in the ocean and would interact with the environment just passively. So, to some extent actively. So when there was nutrients around, then the cells could take those in. And if there were toxins, couldn't do much. But then cells started to develop a way to chemically accept nutritious things and exclude non-nutritious things. At a certain point, then single cell organisms or unicellular organisms develop motility. So they could have tails or little, I don't remember the word, but I think it's cilia or something, to move around through space and move towards whatever was nourishing them and away from whatever was threatening them, all in this effort to keep their bodies intact and to keep the functions inside their bodies going on. And different unicellular organisms had different nutrients. So some were moving towards light and away from darkness. Some would move towards certain chemicals and away from other ones. Some would move towards, would use like magnetic, these organisms still exist, would use magnetic fields to know where to go. And it's all moving the body in space towards what's advantageous for the survival and away from what's not advantageous. And those mechanisms of survival that those cells use, they didn't disappear. We still have them in our body today. But that's just like maybe one of the earliest survival strategies for an organism. Now there's a huge gap in between. We're going to go into this space here. But here now, let's say we're over here as humans, and it doesn't mean that humans are the most evolved things necessarily. I'm just following the path of unicellular organisms to humans because there's different lines, right? And then also mammals came to terrestrial beings and then moved back into the ocean, like whales. So maybe whales are super evolved. Maybe they're just living the best life out there and we don't know about it. There's lots of evidence now about how whales can have advanced forms of communication. Maybe cephalopods like octopode have really interesting ways of experiencing the world. I'm sure they do. They have like really distributed brains and everything. But looking at this line here of unicellular organisms to humans, one of the survival strategies we have as humans is we have this ability to, in any moment, look at the world around us and then create as many imaginary models of what the next moment could look like and the moment after that. So we have the ability to assess patterns, and we're not unique in this. Other species can do this too. This happens here in the prefrontal cortex, but also in the limbic system. So I'll get to where the limbic system is, but the ability to, because that unicellular organism is just reacting to its environment. So whatever's in its immediate environment, it's reacting to. And so light could be here, and like a fly doesn't learn, for example. A fly's got multiple cells, but lots of cells, but a fly's still gonna keep hitting the light, even though it's like, oh, that just hurt. It doesn't have the ability to say, oh, that hurt, I don't wanna do it again. But certain species did develop that. So certain species did develop a way for certain patterns, so the pattern of like that type of pain or the pattern of that type of light, that type of object, to say, yeah, that was really painful. Or, oh, when I moved towards that was really nice and that helped me and that felt good and I was able to live longer. Maybe it doesn't have those thoughts of saying I was able to live longer, but it had some sort of reward system. And then we developed emotions. So actually, going a little bit too far, before that there was the nervous system. So the nervous system can now be distributed and say, I'm sensing something here, let's move the body here. So in essence, we're just talking about a system that can sense the external environment and then move the body in a certain direction. And fast forward, you have worms that were able to sense things in their head and then move their rest of their body in different ways. That's why worms have bigger heads, because you would think about navigating the world with your head first. The most important information is whatever's in front of you. That's what you're about to interact with your whole body. I think it's called encephalization. So we actually have lots of nerves in our heads too, and you can feel the sensitivity of your head if you just go ahead and scratch it with your nails. compassionately and mindfully. So the nervous system developed, and like we can sense something in any part of our body, and we have multiple senses. We can sense with our eyes, with our ears, with our nose, with taste, and then we can have an infinite amount of behaviors from that sensory experience. We also have nerves that are neurons that are just designed to amplify or suppress whatever you're sensing. So information goes from some part of the body. This is nervous system information. It sends an electrical signal along the nerve, and then eventually gets to a point where it synapses with chemicals to another nerve, and goes into the spinal cord, up into a part of the brain that processes that as your subjective experience. But some nerve information doesn't even ever hit the brain. It just goes straight to the spinal cord and back and adjusts. So a lot of the information that you're using right now to just keep yourself balanced in space, you don't even process. It's just going to the spinal cord and back and adjusting the muscle tension automatically. But that doesn't help us develop any patterns and understanding of our environment. We needed a way to store information and pass it on to other species. So then we get into emotions and the limbic system and hormones. And those really help us say, oh, that pattern, that thing was harmful in the past. Yeah. So next time I go and I see that thing, let's create some sense of fear, and let's mobilize the body to get away from it. And that's the fight or flight system. That is the sympathetic nervous system. And the sympathetic nervous system is designed to keep you safe, and it's designed to mobilize the body really quickly. And we hear about this a lot, people being stuck in fight or flight, and that's because you now have this experience of something else we developed. So mammals developed this, which was understanding that cooperation is a really good survival strategy, and that if you see my face and you feel accepted by me and vice versa, then we feel calm because we know that we can support each other, because supporting each other is great. We can do more together than we can do as individuals most of the time if I'm on my game. Otherwise you're gonna have to carry me. So this idea of sympathetic nervous system being activated from social interactions, so perceiving like, oh, my social interaction isn't going well, and now the sympathetic nervous system gets activated and we feel threatened, that's also something that can happen. But the sympathetic nervous system developed, the fight or flight response developed before this whole cooperation structure in mammals. So we're talking about survival strategies being stacked on top of older survival strategies and older systems in the body that now need to integrate with each other in some way. It wasn't like fight or flight developed and was like, oh, I'm also going to be responding to a crisis happening somewhere else in the world that has nothing to do with me right now in this moment, as if it were happening, because yes, it's threatening for humans not to get along with each other, and it's having an effect on my nervous system right now. So a lot of this training is just becoming aware of how stimuli affect the body and affect the nervous system, and from that first person perspective, and exploring it and taking note and becoming more and more aware of that, and finding new patterns that actually help you calm yourself down, because the opposite of the sympathetic nervous system is the parasympathetic nervous system. I shouldn't say opposite because they can go at the same time, but it's important that we stay in this parasympathetic nervous system state often, because it's the rest and digest system, and that is where your body does all the repair and healing and digestion, all the things that need to happen for the organism to keep living. So that whole ability of like mobilize a bunch of energy to fight a threat or get away from a threat, great, really helpful, awesome. And we should exercise that. We should exercise that ability, and it's really empowering to know that you have that ability. So go out there, practice moving your body in a bunch of different ways, practice moving your body in that state of really intense coordination if you want to, if that's something you like to do. I think it'd be really helpful to know that, hey, when I get into that sympathetic nervous system state, I have capacity to be expressive and protect myself. And it doesn't need to be a a confrontational thing. This can be done through sport and play and whatever. It's fine. You're still building those abilities. Like baby animals are obsessed with playing. We kind of stop playing, but what is the advantage of playing? Well, the advantage of playing is you learn how to use your body. So the animals that played the most were like, oh, I want to play and explore my body. Those are the ones that survived the most because they knew how to use their body better than the other ones who weren't as into it. And recognize that you need to get into that state of parasympathetic nervous system rest and digest. Thank you. Have a great rest of your day, and keep sensing compassionately, and keep moving, and sense others and sense the environment around you with compassion, and always sense yourself in that way too. Thank you. Bye.